Okay, so now we are going to enter so that we could do a regression and not just a scatter plot. So this is what we had for a scatter plot. So just wanted to show you how easy it is to go and clean up what you did here. So you go back to stats, you go to edit, and then you go and hit enter. And so notice how I have all this list here. So what I'm going to do is I'm going to go over here and I'm going to erase it, and I'm going to go here and then click clear and then hit enter, and it clears everything off. So then what happens if I delete L1? Oh no, I completely deleted it. Well, I'm going to clear this one here first, so I'm going to clear that up. And then I am going to hit enter, and now it's there. But I no longer have an L1. Even if I scroll over to on there, it won't let me do it. So what you do at this time, and hopefully you understood in the other one, and you already know, I'm going to go down to setup editor. So I'm going to go down to setup editor. You could just hit the number 5 or go there, hit enter. And then it says that, hit enter there till it's done. Then I go back to stats, I go back to edit, and now my L1 is back. So that's how you get the list back if you ever somehow delete one of the lists on there. And so we're going to enter the data for logistics function, and this is from the Federal Bureau of Alcohol, Tobaccos, and Firearms, recorded that the following annual statistics on the number of bombings that have taken place in the United States, and this information is taken from the Cincinnati Enquirer in 1996. So my L1 is still my X values, and my L2 is still going to be my Y values. In this case here, it's a word problem, so my L values, my X values are years, and my Y values are the number of bombings. So the years, it says 1989, 1990, all the way to 1994. So what we want to do here is instead, because anytime you're doing regressions, we want to do the numbers that are smaller. So instead of putting the years 1989, I am going to put in the year 0 for 1989, and then 1990 is 1 year after that, and then 91 is 2 years, then 3 years, then 4 years, then 5 years. And so we are going from 1989 to 1994, where represents 5. So now, if I have that, the problem there is that if it were, because it went up by ones, if it had said 1989 and then 1999, then I would have put in 0 and then 10, and then if the next one was and it goes on 2009 and so on, so it would be 20 on there. So there's usually a pattern in the X values, not so necessarily in the Y values. So in this one here, we know it's 1699, and this is all found in your booklet. Oops, I put it in the wrong one, so let me delete that. Delete, go over here. 1699, 20, 62, 24, 90, 29, okay, and there is a mistake on here. So we have 2062, 2429, 90, and this one here is 2. And that one's okay, so this is the data. So in 1989, there was 1,699 bombings. In 1990, there was 2,060, and so on, 62. Okay, so now that we have that, we have the information. So now we're going to go back, and I know that we're dealing with the logistics function because of the data that's given to us and the word problem that's given to us. But if I didn't know, I would still need to go back and try to figure out. So the first thing that you do after you enter the data is to get a scatter plot. So you have the calculator plot them. So we're going to go here and go to y equals to make sure it's still on. So this is good. And so we're going to hit graph, and again, nothing's there. And so the reason why nothing's there, and usually we don't want to zoom in or zoom out, and usually it's going to be in standard format, and so you have it like that. But we want to change our window manually like we did before, and so we're going to change that. So my X values went from 0 to to 5, so I'm going to change this to -5. There's not a lot of difference, and I'm going to leave that at 10, so it's kind of close there. And then I'm going to leave the scaling for every unit tick mark to be worth 1 unit, and then the smallest value is 16.99, so I'm going to change that to 1,000. And I am going to get the max is 3163, so I'm going to say 3500. And then the scaling there, I'm going to change to 100 because the difference there, every tick mark is going to be worth 100. And then the rest I'm just going to leave. And if you notice on here, you could see that there. So we're going to hit the graph there. And now you could see the actual picture on there. And notice how many tick marks is there. You could actually change that and maybe do every 200. You could even do every 500 on there. And so, but you know that these tick marks are what they're equivalent to. They're each one tick mark. Now, if I didn't know it was a logistics function, it does look like a linear function there that would have gone in there, but I already know that this is a logistics function. And we're trying to get the curve of best fit, so the one that actually goes through the most on there. But because I already know, again, that it's a logistics, we're going to choose that. So what the way that you do this is you're going to go to stats, and now you're going to calculate the equation. And so we want to get the regression equation. So the regression equation just means that it's going to go through as many points as possible, but it's not the exact answer. And so we're going to go over here to calculate. And when you look at this, you're going to have many different equations. I mean, of course, we're going to do logistics, but there is a linear equation here. So number 4, a quadratic equation, a cubic, a quartic, a linear. So I'm going to go, we're not going to use this linear, number 8. We're not going to use that one. We're going to use more like number 4. There's a log regression, natural log regression, exponential regression, power regression, and we're going to talk about that. And this is the logistics equation that we're talking about. But there's also a sine regression, and that's the one that goes up and down for sine and cosine. So that's a sine regression. But we want to do B on there, and we're going to hit enter. And then it's going to tell us, well, where are your X values? Well, we entered them in L1. And where are your Y values? We entered them in L2. Again, you could change that by doing second and 1, 2, or 3. That gives you L1, L2, or L3 there. And we're just going to leave it there. We're going to leave the frequency, and we're going to have it store our regression. We want it to store our regression. So the way that you do that is that you're going to hit this vars. It's right next to the clears button. So we're going to hit vars button right there, and notice how it's red there. And so we are going to go to the Y variables. So Y vars is a Y variable. So we're going to go over. And so we want the function. So we are going to where you're going to store the function. And so then it's going to list the functions, and it's Y1, Y2, Y3. I'm going to put it into Y1. So we hit enter. And so this says that I am going to store the regression equation into my function of Y1. And then we just go down here and calculate. And so we wait for it. It might take long. The longer the bigger the numbers are, the longer it takes to calculate. Now notice how it tells you that this is the logistic equation. So this is C, that's a 1. This is your A, your coefficient, E to the negative B, opposite, not negative B, opposite of B, and to the X. And this is in your exponent. So this is your A, this is your B, and this is your C. Notice how your B is positive, but in the equation it's going to be the opposite of B. So that's what we're going to put in there. It would be a negative 0.5814. So this is the logistics. Now, these are a lot of decimal points, and we do not want to round or truncate at all. We want the actual equation. So that's why we actually asked it to do it. So what we do is we go back to the y equals, and it doesn't show it there, but we go back to the y equals. I'm sorry, to the y equals. I hit the graph button there. It's already graphing because it's already in there, so it's taken a little while. So that's what it looks like. But when we hit the y equals, it's there. So we go to y equals, and the equation is in there. So it actually put it in there. When we did the vars, y vars, and then function, and then y1, it automatically puts it. We don't have to type anything in, and it puts in exactly the whole entire thing. And so that's why you get a nice picture like that. So now let's go back to our graph here and notice that it's there. Now we can't really see much of the graph. We could just see the points. So at this time, we want to adjust our window. So I want to be able to go below the x-axis there. So I'm going to change this here to be maybe, let's go back down to negative 500. And then this one here, we could, I'm going to change that to maybe, oh, good gracious. Okay. Oh, yep. I keep doing that. And so that's a negative, and I can't use the computer negative. Okay. And then I go here and I go 4,000. And then I'm going to change this to every 500. So every tick mark, and we have that. And so now, if I look at it, I'm going to hit graph. Look at how nice the logistics actually looks like. And notice how it's actually going through the points that we have there. It's just pretty much one outlier, but they go pretty close to the regression, and that's what it looks like. And now notice how this is every 500, and this one here is still 1 units. So, and that's what it looks like. And so that's how you get your regression on there. Okay.